Hello everyone, welcome to today's class. This is Teacher Simon taking you through Cambridge International AS and A-Level Mathematics Paper 5-1, May, June 2024. And this is part 1 for questions 1 to 4. Question 1 is coming from statistics and particularly coded data. So they are saying a summary of 20 numbers of x gives summation of x minus 30, which is equal to 439. Summation of x minus 30 squared is equal to 12,405. Then a summary of another 25 values of x gives summation of summation of x minus 30, which is equal to 440. And then summation of x minus 30 squared is equal to 11,346. Find the mean of all the 45 values of x. Remember, when we are finding mean, it is summation of all the values, then divide by how many they are. Okay. Now, I'm going to do something small here for coded data. I can have x values, okay, summation of x. It can be x1 plus x2 plus x3 plus x4 plus many other values. It will be up to xn if there are n x values. So if I have summation of x minus 30, this simply means that I'm going to have every x value here, I subtract 30, x2 minus 30, x3 minus 30, and the rest, okay, up to xn. I also subtract what? 30. However, this one here is the same as saying x1 plus x2 plus x3 plus the up to xn, okay. Then each of these x values we are subtracting 30. Okay, and there are any of them because we have xn. There are any of them. So that means we are subtracting 30 n times. Okay, we are subtracting 30 n times. So meaning summation of x minus 30, okay, is going to be equal to, first of all, this one here is this one. Okay, so we are going to have summation of x minus 30 of n. You see that? So meaning our summation of x is going to be equal to the summation of x minus 30. If I make this one the subject, so I can bring this one this side, plus 30n. Okay. Now, when I'm finding mean, since I'm having two groups, when they say mean of all the 45 values of x, they mean x, not the one which is coded. Okay, so they don't want these ones which are where they have subtracted the 30. So that means we are using this one here. Now, since this is for one group and then we have another group, that means I can have like summation of x. Maybe this is the first group, then I will get for the other group. Okay, then I will divide by how many they are, n1 plus the n2. So that means I'm going to have my mean as mean is going to be equal to summation of x, then plus, let's say, summation of y divided by n1 plus n2. I'm taking this one for the second group. Okay, so since we have seen here that summation of x is equal to this, then plus 30n, that means I will have here, up here we have summation of x minus 30 is given as this one here. So 439, I will have 439, then plus 30 times n. N is the number of values we have, that is 20, so times 20. That is for one group. Then the other group, summation of x minus 30 is 470. So I'll have 470, then plus 30 times, they are 25. Okay, they are 25. So that is for the other group. Then I will divide by these ones, we have 20 and then plus the 25, or I can just say 45. Okay, so when I put in the calculator, what do I get? We have 439, then plus 30 times 20, then plus the other group, we have 470, then plus 30 times 25. Then down we have 45. And this one gives us 50.2. So mean is therefore 50.2, and it is exact. So next, they want us to find the standard deviation for all 45 values of x. One thing you need to know is that in coding, standard deviation and variance, okay, are not affected by coding. I can prove this, but we don't have time, and it is not actually required in the Cambridge curriculum to have these properties, like maybe to prove them or even to outline them. But whether you subtract values or you don't subtract values on these data points given, the standard deviation and the variance will always remain the same, okay? So meaning, if I want to find the standard deviation, it is remember, standard deviation will get summation of x squared, okay? Then out of n, then minus summation of x over n, then squared, you see? And then we take the square root, because what is inside here is the variance. But now we are having two groups. So if I have two groups, that means I'll take the summation of one group, and I also add the one for the other group to get for the total. Okay, so that means we are going to have the standard deviation, the square root of summation of, let's say, x minus 30 squared, that is for one group. Then I'm going to write here summation of, let's say, y minus 30 for the other group. I'm using y just to separate them, so that I can have two different groups. So this is n1 plus n2, and then I will subtract then the mean that we have gotten up there. So if this is coding, if you are using coding here, even the mean you are using here must be coded. Don't use this one here that you have gotten for the real values, is for the uncoded data. So here I will also use the coded data. So plus the summation of y minus 30, then out of the n1 plus n2, and then I will square these ones here. Now I can substitute this one here. I think it is given up here for both of them. So you see this value here, 12,405, and then 11,346. So those are the ones that we are going to use there. So I'll have the square root of 12405, then I will add 11346, then I will divide by 45, okay? 20 plus the 45, then subtract, then 439 plus 470, then also here divide by the 45, then we square. So when we put all of this in the calculator, what do we get? We shall have square root of 12405 plus 11346 divided by 45. Then we shall subtract. I can open the brackets here. Then I put this fraction 439, then plus 470. Then down here I have 45. Then close the brackets and then I square. So altogether we get 10.9 to three significant figures. So we shall write here 10.9 to three significant figures. As simple as that. Question 2 is coming from normal distribution. They are saying the lengths of the tails of adult raccoons of a certain species are normally distributed with a mean of 28 and standard deviation 3.3 centimeters. Part A, find the probability that a randomly chosen adult raccoon of this species has a tail length between 23 centimeters and 35 centimeters. Okay, now our random variable here is for the lengths of tails. So if I have a probability of, it is in between 23 and 35. So 23 less than x less than 35. Then I'm going to standardize this. Remember, when we are standardizing, z is equal to x minus mean, then divide by the standard deviation. So I'll put probability of this is 23, then minus the mean, which is given as 28, then divide by the standard deviation at 3.3, then less than. Now where there is x, we put z. Then this one is going to be 35 minus the 28, then again divide by 3.3. Okay, then I can simplify this. When I put in the calculator, what do they give me? We have 23 minus 28, then out of 3.3. That one gives us negative 50 over 53. Over 33. How about this one here? We have 35 minus 28 over 3.3. That is 70 over 33. So I can write probability of negative 50 over 33 less than z less than 70 over 33. Now, I can draw my bell-shaped curve here. The negative is this side. Remember, for the mean, for the standardized normal distribution, mean is 0. And then here we are going to have negative 50 over 33, which is this side, and then the 70 over 33, the positive one this side. So we want the probability in between here. That means I can get the probability of less than this one, then minus less than this one. Okay, so we are going to have probability of z less than 70 over 33. Then we subtract probability of z, which is less than negative 50 over 33. Okay, if you have a good calculator, you can get these answers straight away. So let me show you how to do this one here. So you will come to mode, okay, and then you go to statistics, which is 3, option 3. And then this will come on your screen, but then you press SC. Okay, then after pressing SC, you now go to shift, then you come to 1. That is where we are seeing start. So press 1, and then distribution, that is normal distribution, that is option 5. Then P is for less than, R is for greater than. Okay, we are going to use those two. But now, since here we are having less than, I'm going to take P. So you press 1. Okay, then we shall have, this one is 70. So just put the 70 over 33. You see, 0.98305. 0.98305. The calculator gives up to 5 decimal places. There are some calculators which can give up to 8 decimal places, like the one I have on the phone. But this one can give up to 5. Then how about this other one here? I'll just come back to this. Since it is P, the less than, I don't need to disturb myself. I just come here, and then I change to the negative 50. Okay, over 33. Then it will give me, then what do we get when we subtract them? So we can get 0.98305, then minus 0.064867. Now that one will give us that value, but I'm going to write to 3 significant figures, because most of the answers in the marking schemes are to 3 significant figures. So that one is going to be 0.918, 0.918 to 3 significant figures. That is that. Next, the masses of adult raccoons of this species are normally distributed with mean 8.5 kilograms and standard deviation sigma kilograms. 75% of the adult raccoons of this species have a mass greater than 7.6 kilograms. And we are told here for part B to find the value of the sigma. Okay, now we have probability of x greater than 7.6. That is what is given. Greater than, okay, is equal to 0.75. Okay, the 75%. Now that means I have something like this. In fact, I can standardize this and I write probability of z greater than this one can be standardized and it goes to a Z value, which I can call Z1, which is equal to 0.75. So meaning, now we need to find the Z value, okay, whose probability is the one which is 0.75. So the Z value can be positive or negative. So what do you do in order to find out whether Z is positive or negative? So this Z1, I can put it here, it's positive, or I can put it here, it is negative. Remember, this is 0 in the middle, okay? And then we are looking at greater than. So look at the right, this one here or this one here. Now, when you look at these two, which one do you think is the one that can correspond to 0.75? Remember, for any barrel-shaped curve, when you divide it into two, this one is 0.5 and also this other part is 0.5, okay? So automatically, you can't call this one to be the 0.75 because it is small. Already, the half of this one is supposed to give you the 0.5. You get it? So that means it has to be this one here, where the Z1 is going to be a negative, okay? So I will say minus Z1 is going to be the phi inverse, okay? The phi inverse of the 0.75. Then I will go to the normal distribution table and I will look out for this value, okay? So when we go to the normal distribution table, which is readily given in the list of formulae, but for this one, you can actually come down here where there are critical values, these ones here. Okay, so we can get for 75 is here, 0.75, the p-value is here. That means the Z is this one, 0.674. So I just go back and I pick that value, 0. So that means our Z1 is going to be negative 0.674. Okay, remember there is a negative here. This one is positive. Okay, it is like this. Then I divide all through by the negative. Okay. So that is how I get that. Now, we know up here, I told you that Z is equal to X minus mu out of the standard deviation. So that means we shall have that Z1, we shall say that Z1, which is negative 0.674, which is equal to our X value is the 7.6, then minus the mu. Mu is given as 8.5. Yes, it is here, 8.5. So we put here 8.5, then we divide by the standard deviation. Now we need to find this value. So when I cross multiply, the standard deviation is going to be equal to the 7.6 minus the 8.5. Then we divide by negative 0.674. And then to three significant figures, what is the value of sigma here? So 7.6 minus 8.5. Then we divide by negative 0.674. So what does this one give us? We have 1.3 and the rest of those figures, but to three significant figures, it will be 1.34. That is to three significant figures. As simple as that. Question 3 is coming from statistics and particularly from representation of data. The heights in centimeters of 200 adults in Barimba are summarized in the following table. We are given this table here. This is for group T data, and we are told to draw the histogram. So the histogram, we are supposed to plot frequency against the class boundaries. That is when the class widths are equal. But when you look at the class widths here are different. Like when I look at this one, the class width is actually 20. When you get 150 minus 130. And then for this next one, it is 10. Then here we are having 10. Then here it is 5. And then here it is 20. You see that? So since they are not the same, then that means we are going to get frequency density. So we plot frequency density against the class boundaries. And how do we get the frequency density? Okay. Frequency density is equal to frequency divided by the class width. Now, I'm going to add on something here, small, and then we calculate the frequency densities. And there is a mark for them. Okay. There is a mark for finding these frequency densities. You get the frequency for each group, then divide by the class width. So frequency density is equal to the frequency over the class width. So the frequency here is 16. Then we divide by the class width, which is 20. This one will give us 0.8. Okay. And then here the frequency is 32. Then we can divide by 10. This one is going to give us 32. Okay. So these are the values that I need. Then I have here 76. I'm going to divide it by 10. This one will give me 7.6. Okay. Then the next one is going to be 64 divided by 5. And this one will give us 12.8. Okay. Then the next one is going to be 12 divided by 20, which is going to give us 0.6. So these are the ones that we are going to plot here. And you make sure that when you are drawing your graph, it should cover at least 3/4 of that grid. Okay. So you get your ruler and then you draw the axis. Okay. So this is my axis here for the frequency densities. And then I can draw this one down here, just like that. And then, since the classes here are beginning from 130, then to 195, so I can take my 130 as the first one. Okay, so let me put for the axis, of course, you must put these arrows to show where the values are increasing. So I can put here 130, and then I can skip like 10 small boxes. So this will be 150, 40, this is 150. The scale has to be uniform, okay? The scale has to be uniform for this horizontal axis. So you have to be very careful here. You don't use the classes which are used there, that you put here, let's say 130, then after 2 small boxes, after 2 squares, then you put 150 like that, because the classes you are given here, they don't have the same class widths. So make sure that the scale you use down here is uniform. So I will have 160, then here 170, then here 180, then here 190, and then of course this one will be 200. Okay, and then you label your axes. So these are class boundaries, but they are coming from height, which is given in centimeters. Okay, then up here on the vertical axis, we are having frequency density. So you also write this one as frequency density. Don't write FD, just write it in full: frequency density. Okay, now after that, I'm also supposed to put what we call I'm supposed to put the uniform scale. So since my biggest here, I can see is 12.8, and there is a 0 point something. That means I can use 1. So for every 1 centimeter, I can put 1 unit. Okay, and for 1 centimeter, that one we are having 5 small boxes. So I'll put here 1, then 2. Make sure that you mark your axis. 1, 2, 3, 4, 5. Then I'll put 3 here. So 1 small box here. Okay, 1 small box is equivalent to, we are having 1 unit. So we shall divide by, how many small boxes are there? These ones are 5. So divide by 5. 1 small box is therefore equivalent to 0.2. You see that? So that is that. Now let us plot. We have this one here, 130 to 150, 0.8. 130 to 150, 0.8. So I'm supposed to take 4 small boxes up here. Remember, each small box is equivalent to 0.2. So that is the first one there. Then the next one, from 150 to 160, 3.2. 150 to 160, 3.2. So I'm supposed to go 1 small box above the 3. So we get something like that. Then connect this one to this. 160 here. Then the next one is going to be 160 to 170, 7.6. 160 to 170, and we have 7.6. So above 7, I'll put 3. I'll go 3 small boxes. So 1, 2, 3. It will be there, 170. So connect with this one here and also down here. Just like that. Then the next one, we are going to go to 170 to 175, 12.8. So 12.8, 170 to 170 to 175. It's in the middle here. Okay, now we are going to go to, this is 12.8. So it's almost 13. So one small box before 13. So I remove one small box on 13. So it has to be there, but then this one goes up to there, because remember, this is up to 135. 175. So this is the one here. Then after that, we are also going to have 175 to 195, 0.6. 175 to 195. That is 0.6. So 0.6 is 3 small boxes. 1, 2, 3. So it will be here at 195. It will be here. So that is going to be our graph. I think you can see that it has covered almost 3/4 of the grid. Okay, that's a perfect graph. Then part B, the interquartile range is R. Show that R is not greater than 5. So now here we are supposed to calculate the greatest interquartile range. Okay, interquartile range R, show that it's not greater than, so not greater than, less than or equal. So it cannot be greater than the 15. So let's just calculate the greatest IQR. Okay, calculate the greatest IQR. Now remember, IQR, we are going to get the upper quartile minus the lower quartile. So the lower quartile, Q1, is, remember, it's a quarter of the summation of F. So that value, this is the 50th value. Okay, the 50th value. And then the Q3 is the 3/4 of the summation of F. 50 times 3, that will be 150. Okay, 150th value. Now we need to find the classes within which these values lie. Okay, and to do this, we use cumulative frequencies. Okay, we use cumulative frequencies. Just use this one here. You can have the cumulative frequencies here. Now for this one, the frequency is 16. Now add 32. What do you get? You will get 48. Then now add 76. We shall get 124. Then plus 64. Then that one will give us 188. And then plus 12. Then you get the 200. Of course, the last value you get for cumulative frequencies has to always correspond to the total given here. Now, after that, we are supposed to look out for which values. The values that we have here are the 50th value. So the 50th value, where does it lie? First of all, these are 48 values. So you have exhausted all of them up to here. That means the 50th value will now fall here. Okay, up to the 124th value. That's what it means. Okay, so it will fall in here. So I'll pick this as my class here, where the 50th value lie. In other words, the Q1. So I'll write this one here, the class within which it lies. This is 160 less than or equal to H less than 170. Okay, then let's go to 150th value. Where does it lie? So for 150th value, already this is 188. Okay, now, and This one is 124. So that means up to here, we have exhausted up to 124th value. So the 150th value has to lie in here, because 125th, 26th, and up to 188th, it is within here. So that means 150 is within this one here. So we shall take 170 to 175. So the class here is 170 to 175. Now, what do we need to find here? The greatest IQR. So I can just say IQR max or maximum. So since it is supposed to be Q3 minus Q1, okay? So if I want to get the greatest value, that means I have to get the maximum of this one, then minus the minimum. You want to remain with something big. That means you will subtract something small on that big thing. So the QR, the Q3 max is here, the greatest here, 175. Okay, and then this is its minimum. Are we there? Then for Q1, its minimum is this one, its maximum is this. So I will take the minimum for Q1 and then the maximum for Q3. So I'll have 175, then minus 160. And the answer I get here is 15. You see? So remember, they said that show that R is not greater than 15. Okay? So this actually shows that the greatest IQR can be, the greatest the IQR can be is 15. So it cannot exceed that 15. You get it? So that is that. Question 4. A game for 2 players is played using a fair-sided dice with sides numbered 1, 2, 3, and 4. One turn consists of throwing the dice repeatedly up to a maximum of 3 times. When a 4 is obtained, no further throws are made during that turn. A player who obtains a 4 in their turn scores 1 point. Show that the probability that a player obtains a 4 in one turn is 37 over 64. I think in this paper, this was one of the numbers that really disturbed students. Okay, but since I'm having these numbers here, there are 4 of them. That means the probability of getting a 4 here is 1 over 4. Okay, and the probability of not getting a 4. In fact, this one can be my P, and this might be my Q. The probability of not getting a 4, which will be 3 over 4. Okay. Now, since they said that when a 4 is obtained, no further throws are made during that turn. So this one qualifies it to be a geometric. Okay, this one is a geometric. Because for the geometric distribution, that is when we do the experiment repeatedly until we get our desired result. You see that? And for a turn, they said that it is thrown repeatedly up to a maximum of 3 times. So when you throw, you can get the success or you can get the failure. So when you fail, then you can continue and throw again. You get the success. If you fail, then you can throw another one. Okay? So this one here is our turn. Okay? That one is going to be our turn here. Now, they want us to find a probability that a player obtains a 4 in one turn. So if I let my x to be the random variable that represents the number of turns, okay? So for one turn, I will say probability of x is equal to 1, okay? This one can be, that is when you are obtaining a 4. So you can obtain that 4 on the first throw, or on the second one. That means on the first one you failed, or you can obtain that 4 on the third throw. That means on the first and the second you failed. Okay, so meaning I can have this scenario here that I have P then plus QP then plus Q squared P. Okay, Q times P, that is the Q squared P. Okay, now putting all of this together, our P, remember, is a quarter. then plus q is 3 over 4, then times a quarter, okay? Then plus 3 over 4 squared, and then times a quarter. So when we put all of this in the calculator, what do we get? 1 over 4, then plus, this will be 3 over 16, okay? Then plus, this will be 9 over 4 squared times 4, that will be 64, okay? So this will be 37 over 64. 37 over 64, which they wanted us to find. Alternatively, I can use another option, okay? You look here. My probability of x is equal to 1 is going to be, remember I took this option p, then qp, and then q squared p, okay? Now, do you realize that this option here is not taken into account? The 3 q's. That means I can say the total probability, which is 1, then minus the q cubed. Instead of me adding all of this, I can just get this one which is left out, and then I subtract it from 1. Okay? So if we say 1 minus the 3 over 4 cubed, do we get the answer? We have 1 minus, then 3 divided by 4, and then we cube it. Perfect. We get it. 37 out of 64. 37 out of 64. So just like that. Okay, let's continue. They are saying Zeno and Yao play this game. Part B, find a probability that neither Zeno nor Yao score any points in their first 2 turns. Remember, a turn comprises of 3 throws, just like we have here. So if it is 2 turns, that means we shall get another one here, okay? That is what it means. Now, I'm going to have x to represent Yao, okay? My x to represent, Zeno, and then y to represent Yao. So neither any of them scores the points. So that means we are going to have the probability of this x here, then we shall multiply by the probability of y here. They are not scoring. So if they are not scoring a point, in fact, I can put maybe complement. They are not scoring, probably. Okay. Now, what I'm going to use here is this one. Let me first copy it. Okay. And I bring it down here such that I can put on the next one. Okay. So let me bring this one down here, just down here. And then I can copy it, then add something here. So this one here, okay, is for 1 turn. 1 turn. And then this one here is another turn. Also 1 turn. So maybe this is the first turn, and then here we can say second turn. This is now for Zeno. So if Zeno scores no point, that means it is going to be only here q cubed, no point. And also here q cubed, so it becomes q power 6. You see that? So we shall have q power 6. That is for Zeno. But this is going to be the same thing for Yao, because they are playing the same game. So this one is also going to be q power 6. So, and our q is 0.75. So 0.75 or 3 over 4. So power 6. You will also get this one here. You power it with a 6. So in other words, I'm going to have 3 over 4 power 12. So what do we get? We can have 3 over 4, then power 12. So this one will give us 0.0316 and the rest of those figures, but the three significant figures, that will be 0.0317. 0.0317. The three significant figures. That is that. Now part C, Zeno and Yao each have 3 turns. Find the probability that Zeno scores 2 more points than Yao. Zeno scores 2 more points than Yao. So I can have my scenarios here. Okay. These are the scenarios. I have Zeno here and I have Yao here. Now, Zeno can score 2 points. That means Yao can score no point. Remember, they are doing 3 turns. So that means this person is throwing 9 times because a turn has 3 throws. And in a throw, when a 4 appears, that's a success, right? So this one can get a point, can get 2 points here, and then Yao gets 0 points. Another possibility is that this one can get the 3 points, and then this one gets 1 point. Okay? When you get 3 minus 1, you get 2. 2 minus 0, you get 2. Okay? Now, I will let my x to represent a point scored by Zeno in a turn. And then maybe the x prime to be the event where Zeno fails to score a point in a turn. The same for y and y prime for Zeno. Now, first of all, we know that probability of scoring a point, that is when a 4 appears, okay, of scoring a point. We have seen right away in part A, it was 37 out of 64. Therefore, what is the probability of not scoring a point? Probability of not scoring a point. So this one automatically is going to be 1 minus the 37 over 64. So this will be 64 minus 37. That one will give us 27 over 64. Okay. Now, let us look at these 2 scenarios. Zeno scores 2 points and Yao scores no point. So, what is going to be this probability here? The probability here is going to be, first of all, I can have, remember all of them are having 3 turns. So I can have Zeno score as a point in the first turn, score as a point in the second turn, but fails to score a point, okay, fails to score a point on the third turn. Then next we have Yao failing to score on the first turn, failing to score on the second turn, failing to score on the third turn. You see, that's why it means 0. Now, in order to save the space, I'm going to just say Yao fails to score the points, then I just put this one as cubed. You see that? But now here, we are considering Zeno scoring a point on the first turn, second turn, and then fails here. Now, there are also other possibilities that can score a point here. On the second one, he fails and then scores here. Okay? So in other words, just shift this until it comes to this other side. So what else do I have? Now I'm just going to replicate this very fast. So I can replicate this one here. And then also another one just like that. Okay, so let me put a plus here, and then I'm going to remove this one here. So let me put this one here. Okay, and then I also remove this one here, then I'll put it here. Okay, those are 3 times. Now, how are we going to write these probabilities? So scoring a point, remember it is 37 out of 64, okay? Then I will also multiply by 37 out of 64 here. So I will just square it, okay, for these two. Then times, for x prime, not scoring a point, it is 27 over 64. So that is 27 over 64, okay? This is now for Yao. But that is for Zeno. Now for Yao, doesn't score a point. It is 27 over 64. Then I will cube it. Okay? All right. Now you can see that it is going to be the same for here and here. Okay? So what do I need to do? There are three possibilities. So I will just say this one times 3. Okay? As simple as that. I will just say that times 3. Because I'm going to have the 37s, 2 of them here. Then the 27s over 64 will be to the power of 3. They will be appearing 3 times. So that is what we are going to have there. Now, what does this one give us actually? So let's check it out. So we have 3 times. Then I can have, this is 37 out of 64. Then I square it. Then times, I'm actually going to put 27 here to the power of 4. 27 over 64 to the power of 4. Just like that. Then our answer is going to be 0.03176, 0.0317614.2. Okay, I'll just stop there. Then I can also go to Zeno scoring 3 points and Yao scores 1 point. Okay, so what is going to be our probability here? Probability is going to be equal to Zeno scores the 3 points, so I will say x, then x, and then x. So since there is nothing different here, I'll just put x cubed. Okay, x cubed. And then Yao, now Yao can score a point here, and then the other 2, he fails, like this. Okay, so then the next one is also going to be Zeno scoring the 3, and then we can juggle this one. Let this one go up to that side. So we can have here failing, then scores, and then fails. And then the last one is here fails, and then scores. Okay, so like that. Now, for Yao scoring the 3 points, remember the probability of scoring a point is 37 out of 64. I'll just cube this one. And then times Yao scores a point, that is 37 over 64. Okay, and then Yao doesn't score the points here, so it is 27 out of 64. I'm just going to square this one. Even this one I will multiply it by 3 because it's the same thing here and here. So we are going to have 3 times, then we have 37 out of 64. Actually, this one I'm going to put it to the power of 4 because you can see there. And then next times, this is 27 out of 64, and this one is squared. So we get 0.059645. 0.059645, and the rest of those other figures. Okay, so now total probability, we are going to add them. So total probability is going to be equal to the first one we got, which is 0.03176, 3176142, then plus this one here 0.059645. But to three significant figures, what do we get? Plus 0.031766142. Then we get 0.0914. 0.0914 to three significant figures. So this has been it for this first part of the paper. Thank you so much for watching. May God bless you. If you find the content very helpful to you, kindly like, share, and even subscribe. See you in the next video.